Hi everyone and welcome to this new video in which I continue my Windows Privilege Escalation series. In this video we will discuss some of the most important files with sensitive data in the Windows operating system. Specifically, we will talk about history logs of PowerShell, about the SAM and system file, and especially the SAM, which is the Security Accounts Manager, and we will talk about how we can dump the contents of this file using mimikatz and the C backup privilege. And then at the end we will talk about the Registry Hives. And as a little extra, I will mention something about configuration file, paging file, and hibernation files, which can also potentially contain sensitive data. However, these things are application dependent, while these other things are always there most of the time, so are more critical, I would say. So, as always, I hope the video is useful, I hope you get something out of it. If you do, leave some feedback, share this video with like-minded people, and subscribe to the channel to help me grow. That's it, enjoy the video. So let's discuss history logs. Now, any command we write using PowerShell could be saved in the history, which is a txt file. It's a simple file that contains the command history. So the history of all the commands that we wrote. Now, to get the history in the current PowerShell session, we can use the command get history. For example, consider this is a Windows 10 machine. We can open a PowerShell session here, and we can write a bunch of commands. UMI, ls, dir, cd, cuser, quickemu, desktop, a bunch of commands, perfect. Then we can do the get history, and we will see the current history, the history of the current shell. So the first command we executed was UMI, then we find ls, then we find dir, and then we find cd. So in this list, we just see the commands in the current session. Essentially, notice that we do not get the outputs, but only the command. Now, there is a particular file in which these commands are written, which is the history file. Now, to understand where this file is located, we can use the following command. So get ps readline option history save path. So we do this. So no, actually I copied wrong. So let's clear it. Let's copy it again. And notice here I get cuser quickemu updata roaming Microsoft Windows PowerShell ps readline console history.txt. Now this is a very critical file because sometimes certain commands can take credentials, for example. So I write, for example, a cmd where I put my user ID and I put a password, and this thing will be saved in the command line. So this is the value of the password. This thing will be saved in this file, which means that if I get access to another user PowerShell session, I should check both the history in the current session and also where the history file is located. So let's read the history file on the current machine. So let's clear the screen and let's read this file. So I'm gonna copy the path, and to read it I can do more and then the path. And notice here what do I get? I get a bunch of different things that I've done like the other day to test this out. We will talk about these commands. But essentially here I create a service for the QEMU setup of Windows. I mean, the idea is that in this file you can get a lot of information, even critical ones. So it is considered a file with sensitive data. If a user writes the password into this file and you can read it, then you can maybe obtain a privilege escalation, because maybe you can pivot to a new user, to a service, you can enter into a database. This of course depends on the application. And here are the default location for the Windows and Linux. So notice that in Windows we have the app data folder. This is on the user profile, which is the default path for the user. So in my case, it is C users quickemu. And notice that this path is the default one, so nothing special here. There is also in Linux, because you can use PowerShell also in Linux. It's on the local folder in the home directory of the user. And so this covers the history. Very simple, but also very, very important to check anytime you get access to a new system. Always check the history. It could contain sensitive data. Oh, and also, other than checking the history, which is an important file, make sure to check out also the environmental variables. You can do this with the command dir env : because once again, environmental variable could contain sensitive data. This is not a file, strictly speaking. However, it is still very useful because it could contain sensitive data. So that's the idea. Here we have the name of the variable on the left, and on the right we have the value of the variable. So always make sure to check history and environmental variables. Now, another potentially dangerous feature of PowerShell is the transcript feature, which is used to keep track of all the commands we execute. Now, this thing is less obvious to attack, is less common because you actually need to explicitly start a transcript with the following syntax. So you start the command and you give it a path where the log file has to be saved. So in this file, we will log all the commands we write in the session. And then at the end, we just stop the transcript. So for example, if I were to start it in this machine, so here, so if I were to start it here, and then I do a bunch of commands, who am I, dir, whatever. At some point, so like let's go back one directory, I do once again dir, and then I do the stop transcript. So stop transcript. Then the file is this log.txt, and we can see it here in the desktop. And notice that in this case, we see a bunch of general information about the machine and also the commands with the output. So a transcript is actually more rich than the history because the history only contains the command we execute. It does not contain the output, while with a transcript we also obtain the output. This thing, however, is harder to abuse because there is no default path for transcript. The user has to specify such path, and many times users do not transcript stuff. While the history is an implicit mechanism, it is used even if you don't want to, and so it's much more dangerous, the history. Also, with the history, a reason why we typically don't want to execute programs where we put sensitive data into the command itself, like for example, I connect to a VPN and within the command line I also put the password. We don't want that exactly because such commands get logged into the history, and the history is a sensitive file that typically can be read, so we don't want to do that. So a general like best practice when it comes to coding and designing codes is to develop interfaces that do not take sensitive credential within command line parameters, but in case they can ask user input during the execution so that the data is transferred through inter-process communication mechanism to the process itself without being logged in the history. So that's a general idea that we want to implement. And so this is it when it comes to history logs. Now, at this point, we can talk about the more juicy part of the video, which is the SAM file. Now, SAM stands for Security Accounts Manager, and it is a file, it is a critical component of the Windows operating system. Why is it critical? Because it stores user account credentials for local accounts. So, when we have any system that has to do with, that includes an authentication procedure, so where a client interacts with a server to establish a session, generally what do we have? We have that the client has to send authentication credentials, and the server has to check those credentials to make sure that the client is really who or she says to be. Now, how do this process happen? This also happens in a web application. So the idea is that the client sends the username and the password, so username and password to the server. The server has a database that stores information about authenticated user, so a data store. Within this data store, the server does not store the password directly, as that would introduce a security risk, but rather it stores the hash of the password. And we will talk more in detail about hashes in the next video, about hashes in Windows. Now, for this specific video, what we need to know is that the database in question is actually the SAM file. So this file is used to store user account credential for local accounts. If we have an Active Directory environment, this is different. If we are just focusing on a single Windows machine, then the file of interest is the SAM file. So this file includes usernames, password hashes, account information, security identifiers, group memberships, and things of the sort. Now, it is located in the directory C Windows system32/config. For example, here I have my shell here. I can just go into this directory. I can do dir. And notice here I have a bunch of files, and I also have this SAM file right here. So that's the idea. Now, by default, it cannot be directly accessed since it is locked up by the operating system. Now, specifically, there is a process in Windows which is called LSASS, that reads this file, so it locks this file, and this process is used to dealing with authentication. So that's the idea. So typically it cannot be read. However, there are certain situations in which it is possible to obtain a copy of this file. Now here I will mention two different strategies to extract the hashes from this file. One targets the file itself, so we create a copy of the file itself with the cbackup privilege. Another uses mimikatz to dump the information on the process. And actually we're gonna see the second first because it requires an authenticated credential. It requires an administrator user of the machine. So let's say that we have compromised a machine and we are administrator on that machine, then we can use mimikatz. Now, what is mimikatz? Mimikatz is a tool used for penetration testing and red teaming in the context of Windows operating system. This is the GitHub page. So here I put a link to the GitHub page, could be useful. So this is the GitHub page. Here you can see in the releases, you go into the releases, you can get the executable, which essentially is these files, and you can get, for example, the x64 mimikatz.exe or win32 mimikatz.exe. So how do we use it? It's actually very simple. We can use it with these following commands: privilege debug, token elevate, LSA dump sum. Now I will not explain in depth these commands because we will actually use and explain mimikatz more in the Active Directory series. However, how do we use it? What's the idea of mimikatz? The idea of mimikatz is that it's gonna dump the hashes saved within the local security authority subsystem service, which is the LSASS. So we take this command, we execute it here. So here I have saved a copy of mimikatz essentially in, I believe, in downloads. So here I have the mimikatz copy. So that's the idea. And how can we use it? I'm just gonna copy this command and I do this. Okay, here it doesn't get the command. I have to do dot dash. And notice here, what do I obtain? I obtain this output. Now, the most interesting part of this output is that for each user of the machine, look at this. I have for the QuickEmu user, I have the NTLM hash. And for the Leonardo user, I also have the NTLM hash. Now, we will talk about these hashes in the future video, when we talk more in general about Windows hashes. But essentially, we have extracted the sensitive information from the SAM file, this time by targeting the process itself. We're not talking directly to the file, we are targeting the process itself. So that's the idea. And of course, notice that in this machine, I have disabled the antivirus because of course mimikatz is very noisy by default if you don't add anything to protect its execution, and so it gets easily picked up by antivirus, Microsoft Defender, and so on and so forth. So that's the first way in which we can extract the content of the SAM file by going through the LSAS process. Another way instead is by directly copying the SAM file itself. Now, as I said, this cannot always be done, right? However, there is a special privilege called the cbackup privilege that allows user to bypass the typical restriction that happens in file systems in Windows. So if a user, even if it is not an administrator, however, if any user has this privilege, it becomes possible to create copies of the SAM and system files. Now specifically, this privilege allows user or services to backup files. And since some files are locked for various reasons, the privilege by design allows user or services to bypass normal file security restrictions. Typically, it is granted to backup operators, system administrator, and trusted backup software. Now, this is important to know. Since by design, it allows to bypass security restrictions, it introduces a significant security risk to consider. And so the privilege should only be granted to those who strictly need it in order to implement a least privilege approach to protect our system and software. Now, to assign such privilege, you can assign the user you want to the backup operators. So for example, in this case, I can assign the Leonardo user to the backup operators. Now, once we have that privilege, it is possible to copy the SAM and system file with the following two commands. Reg save, I put the name of the key to save, and I put an output path. So for example, in this command, I'm gonna save the SAM file into this specific file, and the system file into these other specific files. Once I have both of these files, there are techniques to extract the NTLM hash contained within them. So let's try it in practice. So right now I'm logged in as QuickEmu, but I want to change the user. I want to go to Leonardo essentially. So now I am logged in as Leonardo, and if you notice the privilege that I have, if I say who am I priv, I have the sebackup privilege and also the restore privilege. Even though I'm not really an administrator user, but I have those privileges because I belong to the backup operators group. So I'm not administrator, but I belong to the backup operators, which is a critical group in terms of security. Now, how do I get a copy of the SAM and system file? Well, I'm just going to do these two commands. So first, let me copy it again. First, notice that this file has been created, sam.hive. And then the second, I have essentially here I just copy it, and I have the system.hive. Now I have both of these files. I can transfer to a Linux box, to a Windows attacker control box, whatever. And from this file, I can extract the NTLM hash. So that's the idea. So these are the two techniques to extract these kind of files from the SAM and system files. Now, the other important topic that we talk about is the registry hives. Now, when it comes to Windows, we have an important data structure, which is the Windows registry. Now, the Windows registry is a hierarchical database structure following a tree-like data structure into registry hives. So, tree-like data structures in computer science have the following form. So we have a root node, which is a starting point, and then these root nodes opens up in different nodes underneath, and so on and so forth. Then each node can open up in different nodes. So this is sort of like an upside tree, because tree typically like they have this trunk, and then they have all the leaves here. Instead we have like the root at the top and then the leaves in the bottom. So that's the idea. Now, in this case, for each tree, we have a specific registry hive. So each hive is made up of multiple keys and values, and these hives are stored as normal files in the operating system. So once again, these files can also contain sensitive data because of their nature. They contain critical configuration, they can contain sensitive data, and so on and so forth. Now, these data sources are also very useful in another context, and specifically for threat intelligence, since the data stored within these hives can be used as indicator of compromise for specific malware. So the idea is that when a malicious software executes on a system, it leaves some traces, and these traces are called IOCs, and you can collect IOCs, you can even sell them to integrate them in various solutions for protecting endpoints. And so the idea is that when I see those kind of indicators in my system, maybe malware is running on my specific system. So the registry is a really important data source that must be considered in general. It typically does not happen, especially for OSCP, like for the exam and things of the sort. Typically, it is not used. However, it is very important to understand how it is structured and how we can view the contents of this data. So here we have a bunch of different registry hives. So we have the classes root, the local machine, the users, the current user, the current config, and these are the respective files on the machine. So this file contains this registry hive, which is abbreviated as HKCR, HKLM, HKU, HKCU, HKCC. So that's the idea. Now, to explore the content of a hive, there is a package, a Python package called regipy. So that's the idea. Consider, for example, so let's go back to essentially, so here I have a Python environment. I can just activate it with .vm bin activate. So here I'm just activating a Python package, but essentially the idea, I can even deactivate it. So what's the idea is, we're gonna create a virtual Python environment in which to install the Registry module. So I'm gonna activate the environment, I'm gonna install the Registry module with pip, and then, for example, I can use something like this. So I can use something like this, like dump.py, this code, which simply lists out all the keys within the registry. And then I can, for example, explore the system registry. So in this case, it's system. Now, of course, I need to get the system registry. So here, maybe I can start an mimikatz listener. And I can use, essentially, let's see if here I've saved something. I don't have it here. But if I go to the other user, to QuickEmu, I should have, so here I'm gonna quickly authenticate with a very simple password. And here in downloads, I should have netcat. So I'm gonna copy, essentially, so I'm gonna do Leonardo desktop, let's go into system Hive, I'm gonna copy it here. So now I have it here. I'm gonna netcat into the my host, and I'm gonna give it the system thing, but I need to do it within a different shell. So I'm gonna use this shell. I'm gonna use C users QuickEmu desktop, actually not desktop but downloads, and then I'm gonna do mcat, then 122.1.431 system. And so with this, we are extracting the system from the Windows virtual machine to our Linux host. Look at this, we have a connection and we have 12 megabytes of data. So this file is actually really big. Now at this point, if we execute our dump Python, we get all the data out. Now, of course, this is like an insane amount of data. It's really not that easy to extract useful stuff. I mean, this is the whole concept of threat intelligence. It is not easy to do, threat intelligence. But essentially, that's the idea. We can potentially extract stuff from this file, and so this is another source of sensitive data. And so far we saw the history, the PowerShell history, the SAM file, and also the LSAS process, which we will discuss more in depth in the Active Directory series, and then the Registry Hives. Now, to finish off the video, 3 quick things. Now, with respect to configuration files, certain locations are most often used by application to store configuration file, and these are, for example, the app data and local app data, which for example, in this case, if I do app data, this is the app data roaming. So in this case, it's this directory. So C user QuickEmu app data roaming. Now you want to check out this directory because it might contain sensitive data regarding the specific application that are installed on your target system. So this cannot be generalized. So it's like I can either bring some example or talk in general. If I want to talk in general, there are no specific paths of exploiting this, like for example, the registry, the SAM, and the history. However, this highly depends on your application. Just make sure to check out this area and also check out if you have folders with names that remind you of application, vulnerable application, and things of the sort. So this is for configuration file, and then we have paging and hibernation. Now these are 2 different files that sometimes are used by Windows to handle memory. For example, the paging file is used to handle the paging mechanism. Now what is paging? The basic idea is that the computer has a finite amount of RAM, for example 8 gigabytes or 16 gigabytes. An application uses a certain amount of this RAM during the various workloads. Now what happens when the RAM is saturated? What happens when the RAM is completely filled up? If the operating system did not do anything extra, the system will simply freeze up because it could not handle all the different workloads. So what's the idea here? The idea here is to use a different mechanism for storing data, specifically the disk, for storing a portion of this RAM. So a portion of this RAM goes into the disk, and the file that contains this portion in the disk, this portion of the RAM, is the page file.sys. So if paging is enabled, the system will create a page file.sys file, and so you want to make sure that if you see something like that, and if you're able to read such content, it could contain sensitive data, because after all, it contains the data of the RAM. And the same thing happens when you turn on the hibernation feature, which allows for a faster startup time. So the idea is that a part of the RAM system is saved into the file, into the disk. So once again, when you have things saved into the disk, they could contain sensitive data. So just watch out for that. And so this is it for this video. In the next video, we will analyze more how hashes are used in Windows. So we will go back to talking about the SEM and to the hashes and to how the hashes are formed, the NTLM hashes and other hashes formats. So as always, I hope the video is interesting. I hope you get something out of it. If you do, leave some feedback, subscribe to the channel, share this video with like-minded people, and to the next video.